I think.
Yes, we are live. Uh, we can go through what I've done with the PCB now today. So I gave gave the order on JLC PCB yesterday. There were some small mistakes already, but they haven't assembled it yet. So I've sent them an email to correct those before assembling.
So wait, they found the mistakes and told you, or you discovered it after ship?
No, after I gave the order. I was looking into the difference between tantalum capacitors and ceramic capacitors. And then like the tantalum, I had used tantalum capacitors and they are polarized, and like two of them are inverted.
Oh,
So after I found, so it should be a small change. Thankfully, it's like
Yeah.
I found it out early enough. But yeah, it's better to use ceramic in general, or well, they are not as reliable, it seems, as the tantalum capacitors.
Why?
And
Why does it
I don't
matter
know.
what kind of capacitor you use?
I think there is some more like tantalum are more reliable. It's a little pricier than ceramic ones. Uh, like I was just trying to read what's the difference between them.
okay.
I assume what we see in most consumer products are just ceramic ones.
Mm.
And they occasionally explode.
The cylindrical ones are electrolytic, right? So is tantalum electrolytic or
No,
non-electrolytic?
it's a compound or element, right?
Yeah, but the capacitors made from it, is it electrolytic? Is it like that? Electrolytic is polarized and ceramic is usually not. So that's why I'm asking.
So they look almost the same. Really
Oh,
small one.
oh, okay. Yeah. So they look the same. The ones I see YouTube videos of them exploding, those are the electrolytic ones that look like cylinders, right? And those are
Yeah.
definitely polarized.
Yeah, actually, I didn't know like there
Oh,
are these different kinds. So initially, I was just using I think it also depends on what kind of circuit you're. For maybe for high frequencies, people use tantalum ones, but I don't think we need that. So initially, I just chose whatever I found on the LCSC. So LCSC is a company, it's a sourcing company for JLC PCB. So basically, like they source all the components from that company. So yeah, LCSC, and then like try to find the components from them. So initially, I just randomly chose tantalum capacitors, and later on, I found that like sourcing them is a little more time
Oh,
consuming. Their lead times are more than ceramic ones. So initially, I chose all tantalum ones, and then like I really found out that their lead times are like 24 days or 20 days, and they were also a little pricier. And then I had to change the layout a bit to like change them to ceramic capacitors. And then tantalum capacitors are also not available in like all the footprints, so the sizes were not available. So I had to change a little bit of the capacitor footprints here and there and the layout.
all right. Okay. Yeah. So this is the latest sort of like change thing, but yeah, what's the beginning of the story? Yeah.
Yeah, so basically I took a template. So KiCad 9 or 8, from starting from 8, it has templates. So basically you can start from template. So what I wanted to do was first of all, make everything 3.3 volts, so all the
mm,
circuits, and um, wanted it so that it could fit on top of a Raspberry Pi. So basically like layout is in the form of a Raspberry Pi hat, and from starting from KiCad 8, you can get like start with template itself. So I started with the template, and then basically placed all the components. So the template comes with basic this component. It's the
We we
Raspberry
can't see what
Pi.
you're looking at.
Okay, just a second. Is it now visible?
Yep.
Yeah. So it comes like with a few of the components already. So when you start a new project.
Wait, this thing on the screen is the Tumblr board replicated
Uh,
here.
no, it's the schematic which I built.
Okay.
Wait a second. Okay. Yeah. So basically, you can start with the template, and then it will come with these pin headers, and some basic layout. And the basic layout will be just these outer lines without any layout, and then there are small cuts here and here. Those cuts are basically for the camera. So there is a camera flex PCB port on the Raspberry Pi. So it's somewhere in here in the middle. There is a cut, and then there are some cuts here for some other ports. So I remove them because like we didn't, or actually right now we don't need it. Maybe in the next iteration we can keep them. But basically this was the initial start to get all the components I want. So what I did was took the basic circuits. So from the Tumblr PCB schematic, I took some of them directly. I copied them here. For example, this one. This is the motor driver. So I went to, so I took the uh, part number for this one. So it's a SparkFun breakout board. And then you can go to Snap EDA on this website. So you can search all the components you want. SparkFun Toshiba. I think it's, yeah, maybe it's not this one. But yeah, if you search on it, then you will get a breakout board for the component you are looking and the footprint for it. So I just downloaded it and imported it into KiCad. So this one is the motor driver, and then I from the previous plugin board I had made, I took some components from there. For example, the LDO. So this generates the 5 volts. So I took this circuit from the previous one, and this I think I took it directly from the data sheet. So I wanted a 3.3 volt generator. So I basically created this. So this component is already available in the KiCad library, and then the rest of the components I read the data sheet and just placed according to what it says. And then I added a USB female port on the board. So in on the tumbler for powering the ESP cam, uh, like like we were using a small battery on top of tumbler. It was powering. So I just put a USB A here, and then basically with the same board we can power the ESP cam too. So there is no data like lines here. Only the power is given here, and then I added a transistor switch and then routed it to the Arduino here. So it can be switched on and off from the ESP32, the main ESP32. And so this motor driver is like motor pins are the JST output pins. sockets. So I just copied it from the Tumblr schematic. I just placed whatever it had. And so there are two of them, motor right, and then I just copied the line names and connected it to the Arduino. And this is the accelerometer on top of the Tumblr board. It has a gyroscope too, and this is also from the Tumblr schematic. And then I added, yeah.
So all the parts that you're just copying from the Tumblr board, are they all available in 3.3 instead of 5? So you're using the 3.3 versions or something?
Well, they are capable of running either on 5 volts or 3.3. So I read the data sheet. So they are digital logic lines. So the high can be either 3.3 or 5.
And is that something you set, or you just use a different pin if you're driving the 3.3, or like how do you do that?
I think the pins are capable itself. So I think there is something called VOH voltage. So the minimum V min OH, it's like the minimum voltage required to register it as high voltage. So it's generally around 2.8 or 2.9. So when you use 3.3, it generally registers as a high in the chip itself.
Okay, so you're saying most of the components on the original Tumblr board are like agnostic to 3.3 versus 5. So which ones are actually sensitive that you have to do something to? Because you also have a USB-A port, and that's 5 volts, right? So it sounds like there's a
Yeah.
mix of voltages going on here. So it's not clear
So
what.
this is so the 5 voltage is only for the ESP cam. So I
Okay.
had to bring it out. Yeah. Yeah, because there is no other way to power that cam. So we could replace it with some other cam, but right now, like I wanted to keep the changes minimum, so I just put a USB-A here. And yeah,
And
this is
USB-Cs are 3.3, right? So,
no USB-C is also 5.
oh,
USB is always 5.
okay, USB is always 5.
And then this is the like a inverter circuit for the motor driver. So the motor driver requires actually two lines for one direction. So what they do is have a inverter in between. So with a single line, you can have like two different signals. So when one goes high, the other goes low. So this is like a inverter circuit. And this also is just copied from the Tumblr board. And then I added this pressure and temperature and pressure sensor here. It's breakout board I had from Amazon. It's I don't know the part number for it, but I think it's a company called Sensorion, which makes this environmental sensors. So initially, I wanted to add a like a air quality sensor, which also measures the carbon dioxide or like whatever the air quality. But I didn't have enough space, so I had to choose a smaller one. So and this package was breakout board was small enough to fit here. And then I also on the Raspberry I brought out a lot of pins from the Arduino, like the SPI pins, I2C pins, and some extra digital IO pins to the pins which are connecting to the this RPI socket. So if you're not using it in RPI, we can just connect pins here, and then we can add extra sensor on top of it. So I've also brought out the UART pins here.
What about power?
So yeah, so it's powered via the 5 volts here.
No, I meant these out pins. Do you also have power out pins if we want to
Yes.
connect an external sensor and so on?
Yeah, so I brought out 3.3 volts, and then I also brought the 5 volts to the RPI pins. And then so I made it so that like I also added a transistor here to turn off the RPI from the ESP32. So basically, like you can, yeah. So right, you could turn off the RPI completely from these pins with this transistor. I don't know, like I think the current rating for this is like 200, 300 milliamps. Maybe it's enough for the RPI. I don't know, but we'll see. But like I brought out a lot of the communication lines on the pins, And then these. So I wanted to basically also try out the LiDAR scanner Venkat and I have, the small ones. So they are like a UART based. So these basically we can have like a SLAM tumbler with SLAM now. And what else is there? Yeah, these are last time I had missed one of the buttons. So there was only one button on the plugin board. So, but ESP, so, and that's why like Mayor had to connect those pins together to
Yeah,
reset it in a specific mode, right? So basically
exactly.
what you were doing was shorting two pins. Now I have it by a button. See. So right now you won't have to like short those pins. You just have to press the buttons in a sequence and then it will be in the boot mode.
So I didn't have to do that. Did you already do that for mine before you gave it to me?
Well, you never. Yes, I did that once. I had to do it once. Yes, but like if sometimes if you might need to go into that specific bootloader mode, and then you might have to do the same sequence.
Okay.
But yeah, with this board, you just have to press the boot button. Keep the boot button pressed. Press the reset button and release it, and then release the boot button, and it will go into the bootloader mode. Yeah. And this is the same JST pin connector for power. I was thinking of adding one more vertical pins, but now the order is already given, maybe in the next iteration. Yeah, and then I added the YaRG rover or the YaRG logo here. So that was also something new I learned.
Okay. But I don't quite. Over here and back. Okay.
No,
Nice.
it's also there here in the corner.
No, I thought that you were making the wire layout. Shows the logo.
No. Well, you can do that, but yeah, silk screens. So basically, after I had done the schematic, I used the design services GLC PCB has. So I did a basic layout. I placed all the components where I wanted them, and then you also have to give the current rating of the different wires. And then like I gave, and then there is some. So they don't do the bomb check. They don't. So they assume that you have the correct footprints, and then they give it out within 1 week. So it's a really good service, time saving, and yeah, I wouldn't be able to do it in such a good layout in such a short period of time.
So this is the actual physical layout of the traces, right?
Yes, yeah. So this is how it will look.
But that's the fun part. It's like a little
How
puzzle.
many? There's multiple layers, right? How many
Yeah.
layers does it end up being?
It's a two-layer board. So these thick lines are for the motor ones, and then yeah, it's a little tedious work, but like you can. I could have done it, but it would have taken much longer. And then I also learned about these via stitching, something called via stitching. You see all these vias.
Yeah.
So they connect the ground planes on the top and the bottom layers. So basically they reduce some EMC emissions, and yeah, there are some technical reasons for it. So I learned about that. So basically all the ground on both. So when you do a ground fill, sometimes there will be an island of ground fill which will not be connected to anywhere. So you can use some via stitching to connect it to the other side.
What's ground fill?
All these big red places you see, the zone fills on the top and bottom layer.
So you can think of that as all solid copper. It's all
yes.
connected.
That's what I was asking. Like physically,
Yeah.
it's solid copper.
Yeah.
Okay.
And then like there is also something called keep out rules. I didn't know that. I was not using it before. So basically there is something called raw rule areas. So sometimes what happens is this ground fill will go into a place where you don't want it to go, and then you see this hatched red line.
Yeah.
This one. So
Yeah,
it's a keep out area. So you can have a rule so that the ground fill doesn't cross this. So if I remove this, the ground fill will come here. But if you don't want something here, you can use a keep out rule like this. And then when you press the ground fill, so it won't cross this. So these are small tricks like I have learned while doing.
But
So
why do
this is
you
to
why
prevent.
do you want it to stop?
Yeah.
I think like sometimes it goes too close to the, and then uh, there are some. For example, I had to do a lot of remove, and then it will form an island here, island
Yeah.
of unconnected copper, and it will be difficult to fill those or
yeah.
connect it to the ground. So if you, for example, here there are a lot of components,
But
and
you have the
some
vias. The vias be used to
yeah, but
connect
then you need the
ground.
ground plane on the other side too, right? So
Right.
you can't just connect because there are traces on the other side too. So you won't have like ground plane always on the other side.
Ah,
So
so
you can't just place vias anywhere. So there has to be a ground plane on the other side if you're doing via stitching. So initially I didn't know about that, but then I tried searching what is this empty areas doing. So for example, here, you if there were like ground fills here, then all these area would be islands of like copper
Right.
connected to nothing, and you can't place via to connect it to the top side here because there are already traces.
Right.
So if I don't want to fill this area, then I keep a keep out rule like this, and
It
then it won't
doesn't
fill it.
figure it out by itself.
Not in KiCad. I don't know about others.
No,
so I
maybe
don't get
sometimes
it.
you want it. That's why.
What's there in the islands if it's not filled with copper? Then is it just the whatever melamine board
Uh,
or something? Like
I
what's
think
in the
whatever the material on the top layer, the finishing layer. I don't know the material they use, but it might be some silk screen material and then some polishing material. I don't know. So whatever the material that is not etched
okay?
uh, on the PCB. Do the design in KiCad. So you also have to specify the output you want back in. So I think they use something called so they have their own design PCB design software called Easy EDA. Initially I started with that, but like I was not getting the intuition to use it. So if and they it's directly connected to the JLC PCB this or the LCSC supplier part supplier company. So you can directly like order the PCB from the uh, design software called Easy EDA itself. So yeah, but like it was not as intuitive to me as KiCad is, or maybe I'm just used to KiCad. So you can specify the output you want, and they will design the layout. And there is like a couple of iterations. They will ask, okay, are these all components placed at the correct place? And then what is the routing enough? And then like after a couple of iterations, I found it good enough, and then I just took whatever they had. And then so in the initial design, I had forgotten this environmental sensor, and then I added this myself, and then design made some changes, and then after the designs was done, basically manufacturability is basically a task in itself. So like you have to check the BOM, and then if all the components are available in the time you need, at the price you need, uh, and then if it's not there, you choose another component. Choosing another component means changing the design and the layout. So I had to do like a few iterations, mainly because of the capacitors. So one of the capacitor, yeah, initially I just randomly chose tantalum ones, and some of the lead times were like 24 days, or so basically we would get it next month, but I wanted it faster, and then I changed it to ceramic ones, and they were like available easily in their inventory, and then I changed it to an, let's see, and then yeah, finally I found some bugs uh, because of the polarity, but So hopefully that is not a big problem. I already emailed them and assembly is not done yet. So
Anuraj, what is a bug in this context?
bug in the sense a mistake. What else? For example,
Yeah,
I think here it will be visible easily. For example, these capacitors are shown here, the same kind, but like the tantalum capacitors are, so they have polarity. So for
right,
example, here, this maybe this is, for example, this is the capacitor, and
right,
then you have to connect it to the positive to the 3.3 and negative to the ground of the capacitor.
right,
So initially, when you place the position file in the manufacturing site, it had placed it on the opposite side, and I didn't check it if the voltages were correct or not. So they are currently placed in the opposite direction, but I emailed them to change it to the correct orientation. But with ceramic ones, there is no problem like that.
right.
So this kind of thing, yeah, are there like debugging tools or simulation tools to help you find them, or was this all manual inspection?
This was manual, but I don't know if there is any simulation tool. Maybe that. Well, even if you do simulation, it would simulate the circuit itself. It won't change the actual layout, right?
Yeah, I
So
guess the
basically,
simulation would not be aware of things like is the capacitor polarized or
yeah,
not. Just actually no, circuits show polarized capacitors in the logic diagram, right?
y-
It's
yeah.
parallel
So
plates
so
versus
basically,
parallel.
behind everything, what KiCad does, there is like a bracket-based language, in which you are basically, and the Python, it's Python based, and Python reads that script. So everything behind KiCad is basically a text. So in theory, you could make a large language model that reads it and the text, and then basically finds out the mistake. So there
The
might also be some
component,
tool, but I don't know.
I definitely like. I remember there being checks that like, oh, you're connecting like 3.3 volts to some pin that is not supposed to be labeled, that's not labeled the same, and it like
Y-
flagging certain errors. Like if the component had the polarity specified in KiCad, it seems like it would have flagged that.
So basically, the problem is not in KiCad. So when you
Oh,
generate
okay.
the production files, there is Excel or CSV file generated that has the orientation of components. So I don't know why it generated the wrong orientation in the CSV. So you have to upload a BOM file and a position file. So the production file generated is basically a BOM file plus position file and the Gerber files. So the position file has the orientation, but when I upload it, sometimes uh, the the orientation of the components is not correct.
Can you show us what that looks like? The CSV of like bomb and positions and stuff.
Yeah, just a second.
It might be useful to see the different parts of the process because there's a lot going on here.
Yeah, so the manufacturing, like like I said, that itself is a task in itself, because and then they don't provide services for it. So you basically, let's see.
So you have to do a checklist of is this available, is this available type of stuff.
Yeah.
Oh, okay. So it's
They don't provide you like, oh, this part. Maybe you would actually like this part instead.
okay. So KiCad generates the bomb and the placement data, and then you send this, and
Yeah, so the KiCad will generate this BOM CSV, position CSV, and the Gerber files
what are
in the
Gerber
production.
files?
Gerber files has basically the production files, which are required for PCB production. I think it's an text-based information of different layers and positions of the silk screen layer, the holes where you have to put. The exact format, I don't know, but yeah, it's basically what the machines use. It's like the what is it called in the 3D printer, the format?
Oh,
G-code.
like STL files?
Yeah. No,
Okay.
the G code. Yeah. So
G
it's
codes.
something similar to G codes. The Gerber files are something similar to G codes for PCB production.
And here the position data, this is only for the parts that you position, but anything you didn't specify, it'll be in the BOM, but not in the position table, right? And they will place it.
No, basically it will give you a warning that the positions of these components are available or not, or do you want to continue or just not place them. So it will give you a warning.
So
So
how do you supply the logical circuit to help them finish all the traces and wiring? Like, where is that defined? Like,
it's in the Gerber file.
okay,
Let's
that's in
see.
the Gerber.
So let's.
Yeah, when I did this for mine, I didn't do assembly, so it was a lot easier from this perspective. I had to do soldering, so that's a whole different problem. But
so this is the starting point when you are beginning to like order a PCB. So this is the screen you will get. You add the Gerber files.
I'm getting it. Wait, why didn't you have to do assembly, Rhett?
because everything that all the components that I used were like solderable. So I just got just the PCB. I had the components already.
Oh, okay.
And I just assembled it myself.
Oh, okay.
So there's no like BOM Excel file that someone else is going to have to deal with.
So yeah, so this is how it will look like.
Okay, so you upload the
Gerber file.
Gerber. That's a funny
And
name.
then yeah, you can also have different colors if you want. So I kept it as green.
Okay.
Oh.
Last time I had
orange.
Yeah, I think you can order orange, but yeah.
Just kidding. I don't think it matters. If we do branding.
So the PCB is
Doesn't
really
the
cheap.
YaRG Rover have a design system that we're supposed to have specific branding requirements around PCBs and logo placement, size?
Yeah, and then some of the components were too small, so there are like two versions of it: the standard and the economic one in the assembly. So let's go with the standard one. And so the actual production of the PCB is just 2 or 3 euros. It's just rest of the components placing and other stuff that costs more.
And this is somebody manually doing it. Like they'll be looking at your CSVs and.
So there is so they have an engineering team there. So the initial screening is just automated like this. So I just uploaded the Gerber file, and then it just looked at everything and then generated these costing things. But before they produce it, it goes through a design for manufacturing team, which looks at everything. And then if they see a problem, they will contact you. And this is like the assembly. So I had to do the standard one because some of the components are too small. And then yeah, you can have like deep panel the boards. Basically they will cut out so they make it in a panel generally, and then if you want them to already cut it separate it after manufacturing, they will do it for you. So there is a small cost for it. I think 7 cents or something.
You mean like multiple PCBs connected in like a larger?
Yeah, it's all the PCBs, like they put it on a large panel.
Okay.
And then yeah. So if you don't specifically ask them to depanel it, they will give you the entire panel together.
Yeah, this is like printing. In printing, you can print documents like 2 up, 4 up, and then if you don't specify cut it, it'll be like you'll get a book with 6 pages laid out.
Yeah, so it adds some like 10 cents or something for depaneling. And then yeah, these are
What
this.
is baked components? Is that like oven baking to harden the glue or something?
Yeah, so I think they bake it so that the soldering is a little better.
Okay.
So I think moisture sensitive components can reduce the risk of package damage.
And I didn't understand what you said about the standard versus the special one and small components. What?
I think so. The panel size changes when you use the standard one. What's the difference? Yeah.
Oh, the economic is okay. So must be coarser or something like
Yeah,
resolution.
I think the automated machines might also be different. The capabilities of it.
Oh yeah, it says here 10 by 10 millimeter. This is 70 by no, actually that is larger. So there must be a resolution number somewhere.
Yeah, so the panel size is this, and yeah, the minimum package. So I had used smaller packages than this one. I had used like even a smaller one. So this was the
Okay,
reason.
that's the one. It's okay. This is
And then you go to the next phase. This is the bottom and the top. Next, and this is where you add the bomb files. File, and then you add the position file. So this is the warning that these things are not does not. So I basically deleted it from the bomb file because I didn't want them placed. So the A2 is the Arduino. Environment sensor is basically the breakout board. J3 I don't remember, but yeah. PU2 is the motor controller. So these I deleted from the bomb file, so it's giving a warning. But yeah, I just don't them on, so I continue.
but these are things you will add or they will add separately in the assembly.
No, it's just a through hole, right? So it's
Oh, okay.
basically this.
But what's your plan? I mean, are you going to have them buy the component and solder it there,
No, I have this. Can
or
you
you
see
have
this?
it so you'll do it when it gets there?
Yeah, it's just a breakout board.
Okay.
So I'll just plug it in into the. So I'll add a female header on the Raspberry Pi hat and then plug this sensor in. And this is where the iteration starts.
Which
So
of the
basically,
components is like one of the components is like €3?
which one?
Oh, I guess the top one's like 5. What is that? Oh, those are your capacitors. What? Oh, 10 of them.
Yes. So they are tantalum capacitors. That's why they are expensive.
But you've replaced them now, right? With
No. So some of them were already there in their inventory, so I didn't change it. And there was like a few of them were not in the inventory, and then I had to pre-order them from their website, and the lead time was 24 days. So it would arrive next month.
and the
So that
three
was
dollar
like a little
one is also no, that
tantalum, but it was already there in their inventory. So I just took it.
so
So
these are
whatever was there in
they're much
So
more
whatever was there in there, yeah. So they are much more expensive, but they are much more reliable. But in the next iteration, we can replace it with like. So this was like I realized this after several iterations. You start learning all these small information bits and pieces of information from here and there, and then yeah, it was basically like I wanted to do it as fast as possible. So whatever was there, and yeah, so this is like the first time you do come here, some of the components might not be in the inventory, and then when you in on the same screen itself, it will provide a search function for the component it has not found in their inventory, and then it will ask you, do you want to replace this component? So each one of the component has a LCSC part number.
are those the information like yellow icons are the ones that you need to that those are warnings?
Yeah, so it will give a warning here, and then actually there will be a separate section at the bottom. The component has found in their inventory, and the components which are not there in their inventory.
Okay.
The ones which are not there, it will be in a separate section at the bottom, and then it will give you a search function to find like the components you want. So basically, a similar search function will be on the same, but I was just trying to directly find it from the LCSC component. So for example, this is a ceramic capacitor, and then ceramic capacitors have a LCSC part number. So this is what you have to specify here in the manufacturing. Uh, these numbers are basically LCSC part numbers.
Okay.
You have to
And
specify them.
And these two are separate companies, JLC, PCB, and
I think there is some relation. Maybe it's a subsidiary. I don't know exactly, but yeah, maybe it's a separate company. But this is a large supplier company, which many of the PCB manufacturers use. So the ecosystem there is really huge.
amazing.
So there, yeah, and this runs for 24/7. These factories for the entire year, and there are not just one. There are like several of them there in multiple cities. It's like a large scale industrial, and they provide it so cheap. So it's difficult to compete at that scale, I would.
I mean, even besides the cheapness, like just replicating this infrastructure
Ye-
somewhere else, like that. This is what, like, thinking about the tariffs in the US, it kind of makes me laugh. Like, there's no way you can overnight replicate this kind of
Yes,
ecosystem.
this is like a decades of infrastructure building.
Like
So
Silicon
they have
Valley
been
has
doing.
companies that do this, but they're much more high touch and like 100 times the cost and like much smaller scale. So it's like you can do very small prototyping of like high end things, but anything more, you really have to go into the supply chain, I think.
Yeah, besides there is also a lot of manual work, right? So you
Yeah.
have to have an engineering team that basically checks, because if something goes wrong, then there are like customers are not happy, so they go to their competitors. But I think like with robotics and AI might help in bringing the cost down, but these companies might already be doing that, right?
Yeah, but sounds like most of the cost is actually going to be in the engineering labor, right? Like, what's your cost breakdown? The board itself was just a couple of bucks, but it's
Yeah.
the design services. Like, what's, yeah, well, maybe we should look at
Design services was 60 euros,
Okay.
and then the components itself, it was around 50 euros, and then the layout assembly, I would say assembly was around another 50 and then the customs and shipping is another 50, so total around 200.
Wait, I thought you said your total came up to around 700. What is
No,
that?
no, no, no. That was not mine. Somebody from the US has started learning.
Okay,
uh,
okay.
yeah, so
So,
they were just pissed that like the total cost was around 200, but they had to pay a tariff. Together with the tariff, it
oh,
came to around. So
okay.
I had posted it in like YaRG. It was not my
Oh,
cost.
okay. So that was not yours. Okay. I,
Yeah, yeah.
I
But I think
understand.
like if you order it, then it might be expensive for you compared to me.
Okay. I wonder what happens if you order it and then you ship it to me because you're like reshipping from a lower tariff country, right? A lot of people are already doing that. I think a lot of China business is now flowing through like Malaysia and stuff.
Okay. Yeah, but like their entire ecosystem is just amazing.
so, Anuraj, how big is this board compared to the largest board you could do using these services?
I don't know their
Can you give a
capacity.
feeling, for the complexity which is possible, complexity which is typical?
So they can do 32 layers in the standard one, right? So and I think even in the advanced manufacturing, they can do up to like 50 layers or something. So you can do this for real manufacturing of your let's say real product, whatever you are building. And they
How
also have
is a real product?
I've seen people for example I have a debugger called Magic Probe. Do
Okay.
you see this?
Mm-hmm. Yeah.
I think it's a 4-layer board. It's a German company. So it's a debugger probe that I have with a GDB plugin inside.
Okay, it looks pretty simple. Is it more complex than
Ye-
the tumbler board?
It's more complex than what I have. I would say it's
3 layers
four.
is a
Yeah,
lot.
it's 4 layers, four to 6 layers.
Yeah, but layers could just be a way to overcome routing issues. It's not a measure of complexity.
We can
Yesterday
check
I
this.
saw boards, this size, but it was all covered with those tiny ceramic capacitors and power amps and who knows what other eight-legged chips. So I'm just trying to get a feeling for how complicated is this project compared to what you could have done in this ecosystem.
Let's see. I think they keep advertising on their website the kind of designs that do.
Do they offer testing services? Because I think that's another way to
Yeah,
appreciate the complexity question. Because beyond a certain complexity, you'll have to do testing of the board before accepting it. And from watching other people do this at like bigger companies, I know they spend a lot of time in-house defining the tests, then like negotiating like the test suite running with the vendor company, shit like that. So there's a lot of testing.
When you say testing, you mean checking that it was manufactured correctly, or do you mean checking that it does what you think it was supposed to do?
This is with more complex products, you write contracts to cover all this, so there will be errors attributed to poor design, there will be errors attributed to manufacturing errors, there'll be errors that you can't predict, like some
Yeah,
weird
whatever.
voltage leak across a physical barrier kind of thing. So yeah, if it's a big value contract, you will actually write clauses of who's responsible for what, who pays for what, if there's delays, who's responsible, that kind of thing. So but yeah, all of that is linked to who's doing the testing and at what point and at what location, right? So some testing must happen at the design stage before you ship the design. Some testing will happen on site. Some testing will happen after you come back.
Mhm.
So
so basically they at least advertise themselves as a complete uh, partner for your electronics production. So from prototype to mass scale production, they advertise themselves like that. So if you want to maybe ship 1 million pieces, maybe they might be able to do it.
yeah, they probably have like high touch salespeople and
Yeah.
site visits for people who want to do that sort of thing. Like, where are these people based? I'm sure you can visit the factory if you're giving a 10
Yeah,
minute,
yeah.
right?
I think I've seen some videos on the Twitter profile that somebody had gone to China and then they were planning some sort of mass manufacturing of their product after the initial prototypes. So they are based in where?
Must be somewhere in Shenzhen, I guess.
Probably. Okay. Yeah, yeah. Okay. These guys have also done it via GLC PCB. This robot.
Oh, wow, okay.
Oh, wow.
That's a complex thing then. Wait, but they've only done the electronics, right? They're
Yeah,
not
Yeah.
the
full
one on
stack.
the right there looked very nice, the smart home. Yeah, so okay, so they do this kind of stuff as well. How much
And
work,
then
And
and then they take that and they ship it down the street to a different place that does the rest of the assembly.
uh, how much time, Anuraj, would it take you to do the smart house design that they have there?
I don't know if I'm capable of doing that. Maybe if I spend next 2 years learning doing PCB on a daily basis, I might be able to. And even like such designs are not done by one engineer. So you have a team of engineers. So generally, in the previous company I was working, you have a team, and then some people just do schematics. So when you have like really complex designs, like 30 layer, so you have like just a team of electronics engineers doing schematics, and then they just check everything in the schematic is correct, and then you have another team for layout that does just layout. and then there might be another team that just does the manufacturability design or design for
What
manufacturing stuff.
what makes it so complicated?
I mean, think of it
The
as like
same thing that
right? Yeah.
yeah, the same things that make any engineering problem complex, right? It's just the
No,
amount of information our engineer can keep in his head.
but maybe the problem is that you're trying to fit it all on a small board. Maybe what makes it complex is higher frequencies. I mean,
I think it's the sheer number of like components, and it's like the equivalent of lines of code, as I understand it. Like
Yeah.
this is the board level, which is somewhat different from what I've seen more of, which is the silicon level. But there, RTL, the hardware definition language, you can
right.
compare that to code, right? And it's like just how much code can one engineer write in a year. So you kind of have to manage bandwidth. And yeah, the skills are different for people doing like the schematic logic stuff versus the physical design stuff is a different skill set versus verification. So I think
Yeah,
similar.
because in complex design, for example, high frequency, let's say you are doing some modem design or like board for a modem, then there is like you have to consider the RF design or the emissions. So those are like becomes really niche knowledge, and then that for basically what you get after years of experience in that domain, right?
And for larger power things, there's often like several people doing just power management and
Yeah.
thermals. Like the product I'm thinking of, there's the team of people just worrying about temperatures and shit like that is like 2 or 3 people.
Yeah, but like, it seems like I've learned a lot in this iteration. Like just the manufacturability of like how much it's. So you cannot learn this while by reading it somewhere, because all these bits and pieces of information are just scattered everywhere, and then when you only learn it while by encountering it.
Doing it. Yeah. But you could have outsourced most of this work to these suppliers.
Well, I did the most tedious part.
Which is the schematic
No,
logic
the
stuff
layout.
layout.
But isn't that done
The
by?
layout is the most well, it might be tedious for me because I don't know all the tooling. For example, this keep out areas. So I just learned it when I like when I got the design files back. I didn't know something like that you could do in KiCad or any other electronics design. And then this VR stitching is something I learned in this iteration. I didn't know about it.
Yeah, I definitely didn't
Uh,
do that on mine. I didn't know that was something.
But that's only necessary if you have 2 or more layers, right? Like
yeah.
Red, did you have 2 layers in your board?
I think I had fills on both sides because I think maybe that was recommended. But it was a 2-layer board because I definitely needed to route around stuff. And I had vias. I just don't know if I had the stitching.
If you have isolated copper islands, you could have things like ground loops, right? Because then the ground will not be connected properly.
And there are some
KiCad will warn you about it also, which is kind of nice.
there are emission problems too with those like copper islands.
So, what do you do with a copper island? Do you like find a way to connect it to ground in a weird, complicated geometry or something, or do you just
no,
leave
you
it?
remove it.
Or
You
you
remove it, no. So you basically you don't etch. You keep a keep out area like this. For example, if this keep out area is removed, there would be like ground fills here, and it will be difficult to connect it.
Mm-hmm.
So basically, that's why that guy put a keep out area here, probably here.
So this is, and this was just like $60 to do the layout
Yeah.
design. Wow,
Yeah.
that is cheap. This is fairly complicated work. Did they give you an estimate for how many hours it took? Like, what's their hourly rate?
Oh, when you upload the schematic, and then there is an initial estimate, and then an engineer will look at it, and then will. It also depends on the number of pads, the initial estimate, and the number of holes, and the number of layers, and the number of components.
But did they
So
tell you
there is
the actual number of hours it would it took the guy, or
No.
okay, that would
For
be
like, yeah, for some it depends on the experience. So for him it might be, or her, it might be just a like a 2-hour job. But if I do it, it might be like a 1 month job.
okay.
Yeah, so it also depends on the skill level.
Yeah.
And yeah, so some of
It-
them could be automated, maybe, I don't know. So they probably are using some professional, like a paid version of the design software.
but
I
I
think when you
suspect
talked
enough of
about
this is
this,
tedious enough that it won't be. You can't speed it up too much, like even with skill.
Yeah.
A lot of it is just tedious manual stuff.
No, but yeah, tedious in the sense like if you have the shortcuts and the interface in your fingers, then you can just do it really fast, right? But for me, it's like I have to first read, okay, what this button does, and then then maybe do some experiments, and then so it takes time, yeah. But if you have it on your fingers, then you can really do it fast.
You were saying
Some
something
of
more?
the
I was just saying, I thought that when we had talked about PCB stuff before, that Anurag had tried. There was like, because there's like auto routing, like just programmatic routing
yeah
systems, and I think I also tried to use that, and it was just a disaster. Like,
yeah, it depends on like for like if you're using Altium, I think it's a little better than KiCad, the auto routing. So the auto routing here is a free version somebody has designed, and then I placed the components and then did a initial routing, and then gave the half routed. But then he didn't do anything related to the auto routing. He routed it himself, or maybe whatever software they are using. For example, like this, you cannot do it with auto router. So this is the main power line. So I told them it will take like 3 amps. An auto router will not make this, right? And then, for example, auto routing with different lengths of traces, that also a router won't be able to do it. And then, for example, when you are going to the other layer with a different trace length, this cannot be done with an auto router, this 3.3.
wait,
And
what?
this battery.
Wait, why? What do you mean, why not?
It will just connect with the standard trace length. So you want different trace length for different things, right?
But you can. Yeah, I'm pretty sure I remember configuring like different lines and saying what they were. Like you identify certain lines as being all the same thing, and that you could associate that with a
Trace length,
trace
maybe.
width.
Yeah, maybe it's
thought.
possible. For example, but it also
net class, that was the term.
yeah. For example, these voltage down converters, they require specific ground and power, or like layers near them, or specific width or areas. So for power dissipation. So auto router won't be able to read the data sheet. It will just connect with the trace length. But for example, if you want a specific area like this, that won't happen with an auto router.
Yeah.
Anurag, did you use any Chat GPT help to navigate any of this? Because I just asked Chat GPT and it gave a pretty good description of the process, same as you did.
No, I didn't ask anything. Well,
Let me check.
I know a lot of this process already. Like I've been in a manufacturing company, so for me, it's like I'm not able to express it fully, but like for me, like I am familiar with the process of what here.
The reason I'm bringing it up is I think it might be worth using ChatGPT for this because it might be able to help like both flesh out the process and like flag things we may be missing because we're kind of doing like self-learning here. But yeah, I shared my screen. If you share that, we can scroll through it and see if it's the same process as you had. Can you quickly share mine?
Yeah.
Yeah. So I'll scroll through. So yeah, project setup and schematic, similar to what you said. Library management and footprints. I think you covered that too. PCB layout. output generation. Yeah,
Yeah,
this is Gerber files.
yeah, it's pretty accurate.
And then choosing a Chinese manufacturer, JLPCB, it found the one you mentioned, but it mentioned a few others. Uh, Upload files, assembly options, upload parts. I didn't find a particular one, but yeah, these are the things you'll have to do after you get it.
Yeah.
Review
So
production.
what was the prompt you wrote?
Prompt was describe the process of designing a PCB in KiCad and getting layout design completed and board manufactured and assembled from typical Chinese manufacturers. So this was just the first response. I suspect if I ask it detailed follow-up questions, it'll probably know a lot of this. So that's kind of cool. Yeah, I'm probably going to like rewatch this and then sit with ChatGPT for a while to actually see this and see if I can do a simple project to try it myself.
Yeah, actually, you guys should try at least a simple board manufacturing with this Chinese guy. I don't know. It might be a little. If you do a simple board, it might be cheaper right now in the US, but you should try it because you will get familiar with different parts of the
Yeah.
manufacturing process.
Rhett, you
But-
got it manufactured locally, right?
I did, and they do not do assembly either. So that was the other piece there, which I can see like all that. So yours without assembly was like €4 or something,
Yeah.
insanely cheap, right? The one that I had, I think they're based in Oregon. It was like $25, and you get 3 of them, and the board was, that was that big.
Yeah, but it comes to around 25 euros for me too, right? Because it has to be shipped from there.
Oh,
And then I had to pay customs on it. So the price for
Okay,
you and
yeah.
me, like just for the PCB without the assembly, is the same.
yeah. I think
As you had
pre-tariffs,
volume, you can-
it was that cheap from China if I wanted to. Like I was like, well, I'll choose a local one just to see what that's like.
Yeah, I think with high volume, though, the Chinese option will be way cheaper, even with like shipping added, and so long as tariffs are not terrible. Like now, it's going to be 30%, I think. So I think it'll still come out cheaper than doing it in the US. But I think main thing will actually be capacity. It'll be hard to find places that do the full stack thing in the US. Like at least for small amounts like this, there'll be shops doing it for like $1 million contracts, but not for like $1,000 contracts.
Yeah, I wonder if there's anyone actually in the US that does full assembly services like that for the
Oh, it
at
should
the
be there.
hobbyist level.
Yeah, hobbyist level.
Yeah, it might. Yeah, not at the hobbyist level, but I think for companies it might be there in Europe and.
Oh, yeah, that
US.
there is. I know because we work with those companies all the time. But yeah, those are like millions as the minimum order amount before they'll touch anything. Yeah.
So I checked my board and I didn't do a fill on the front. I only did a fill on the back. So I didn't have any, and that was probably because I was getting strange errors, not knowing about the stitching thing. Like to have them connected was unclear.
Yeah, I was thinking about once this starts working, I'll start designing the next iteration of this. So basically, I'll try to remove all the breakout boards and then take directly the ICs from the breakout boards and make that itself.
I suspect you'll have to spin this board at least twice to get it to work. There's enough.
Let's see.
Here.
Yeah.
I thought the same thing. Mine has bugs and it still worked. So maybe there's a lot of leeway.
Yeah, it might be usable, but not like just placing.
Yeah, this is awesome.
But it will be a little more complex when all the breakout boards are removed because all the components are directly, and then it's a much more complex project.
And then the next version is you actually just have them put the ESP32 chip directly on it, and it's just one.
Yeah, that is what I meant.
Oh,
that is
for the whole
what
thing.
I meant.
Okay.
Yeah, for the whole board, I'll remove all this the sockets thing. So the Arduino, instead of Arduino, we directly use ESP32. The motor driver is directly on the the sensors, and this would save a lot of space on the hat itself, and then we can add lot of sensors and like whatever we want to design.
So, so one suggestion I have is for the next one, uh, add capacity for driving 6 motors or even more, because 6 motors gets you to driving the Galaxy rover, right? That has 6 motors. So that's that generalizes to 2 of the rovers. Uh, that should work, right, Rhett? There's no particular reason
You know,
can't-
the current design on that Galaxy one has the motors tied. I think they're tied together.
Oh, okay, but they could
But
potentially.
they could be run independently. Yeah. I was
Yeah,
kind of disappointed when I realized that's what they had done. I was like, oh man. Pretty much everything only seems to have like 2 motor channels.
That is odd. Though I guess it kind of makes sense. There's not many situations where you'd want to drive all 6 motors independently. There's probably just
Yeah.
like configurations of 3+3 or something like that. Yeah, maybe we don't need it. Maybe this alone will be able to drive it.
Actually, there is a general purpose ESP32 based robot controller board. I have posted it somewhere in the YaRG channel, and they have the schematic available. So I had asked them initially, do they have a ESP32 S3 version of it, or are they planning to design it? But if they're not planning to design it, we can take like schematic from there and then either modify this hat or ask some design services to do it for us.
There's also like reference designs for the
Yeah.
ESP32. Also, pretty much all the breakout boards for ESP32s look exactly the same because they're all the reference board with slight modifications.
So it sounds like this entire low-end robotics sector is moving from Arduino to ASP32. Is that correct? For more compute and Wi-Fi capability, basically.
Yeah, mainly for Wi-Fi. So the software stack is really good, I would say. Let's say I know it because I've seen others do it. Like multi-billion-dollar companies are not able to compete with their software stack. It's really nicely done, and they have been doing this for 10 years now. So they are way ahead of everybody. So whatever IoT you are saying, it's like Espressive is nice one.
Yeah,
So-
I still think it's funny though that despite how good it all is, at the like educational level, like these Galaxy things, it's still all about like Arduino compatibility and like the code that the consumer is going to write is going to run on Arduino, even though there's an ESP32 in the project somewhere that's way more powerful. It just does the Wi-Fi so that you can talk to Wi-Fi from your Arduino through a UART to an ESP32.
Is it more powerful because Wi-Fi requires more compute to run? Is that the reason it's more powerful,
Yeah.
or is it also is
Ye-
other independent variables?
And multiple cores, I think, probably.
Oh, well, the Wi-Fi stack might be a little more complex to do on an Arduino or an AVR core. So at least, so generally Wi-Fi stacks are done with the 32-bit compute. So it's
And
ARM
Wi-Fi
or
stacks
Cortex.
are more complex than Bluetooth stacks. Like,
I have never done them, so probably of the same level of. Generally, what these companies do, they provide a binary blob and an API so they don't reveal their Wi-Fi stacks or Bluetooth stacks.
okay, yeah, this might be a conversation with ChatGPT in the future for me. Like, I'm just curious, why is ESP32 different or more powerful than?
Maybe you should do it on DeepSeek, because maybe they have more inside information on Chinese integration protocols.
No, ESP32 is all European, right? Like, Espressif is a European
No.
company. No, where is it?
Chinese
I don't
company.
know who makes
Chinese?
it, but I
China-based.
know who's using
Yeah.
it.
Oh, okay. I thought it
Yeah.
was European for some reason.
It's
Okay.
a Chinese company. I think it's Shanghai based or something. And right now, all their future products and the current products they are promoting is all RISC-V based. So they have already moved, like they're made RISC-V the main core 5 years ago, and their entire software stack is compatible with RISC-V
Ooh.
cores. So I think last week they released a 5 gigahertz microcontroller Wi-Fi. It's called ESP32 C5, and it's 5 gigahertz plus. It's a dual band Wi-Fi. I think it's the first one on a microcontroller. Yeah, so it's
Okay.
really
Huh. So yeah, maybe should talk to DeepSeek about it. We'll get the CCP propaganda version of why it's better. All right. Awesome. Yeah. Looking forward to seeing the boards coming back and seeing if they work.
Yeah. Okay. And see you next week.
Cool.
Bye.
Thanks, guys.
Bye.